Hey guys, welcome to week 3 of At Home Learning. We're going to do Monday's Math Daily Review number 29. So number 1 says, which number below would need to be in the ones place for a number to be odd? So let me set up a 2-digit number and I'm going to show you that this is the ones place. So for example, if you made the number 15, the number 5 would be in the ones place. So let's say we're going to make a 2-digit number and the ones place is going to be 0. So for example, we could make the number 20. Is that odd? No, not odd. Okay. B, let's say 24. Nope, 24 is not odd because 4 is not odd. 25. Yes, 25 is odd. And then let's look at 22. So if we put a 2 in the ones place, that would be even. So that means that the number 25, we could pair up counters or circles. We could make 25 of something. And then when we got down to the 5th one, it would be missing a pair. So it would be the odd one out, which is how you can conceptually understand an odd number. All right, let's look at number 2. Number 2 says, Joe drives to work every Monday, Tuesday, and Wednesday. He lives 12.8 miles from his job. How many miles will Joe drive to work in 8.3 weeks? All right. This is a 2-step problem. The first thing that we need to understand is the number of miles that he travels in 1 week. And then we'll figure out how long it takes him to travel that far for 8.3 weeks. So I know that he lives 12.8 miles from his job. And he travels to his job 3 days out of the week. So the first step for me is to multiply the distance from his job times 3. And that will give me the amount that he travels in 1 week. So since this is a word problem, I am going to use my calculator to multiply that by 3. And that gives us 38.4 miles, for 1 week. Okay, 3 days a week. And so that means that for a total of 1 week, it would take him 38.4 miles to get there over those 3 days. But it says, how many miles will he drive if he is going to work for 8.3 weeks? So the second step means that we need to take that total and we need to multiply that by the total number of weeks we are looking for. So that means that if I calculate Joe's travel, 38.4 miles for 1 week, I'm going to multiply that by 8.3 weeks, and then this should give me the total number of miles. So in 8.3 weeks, he will have traveled 318.72 miles. And there's the total. So let's review it really quick. So the first step is figuring out how many miles he travels in 1 week. So we took 12.8 and we multiplied it by 3 because he goes to work on Monday, Tuesday, and Wednesday. And then the second step was that we multiplied it by 8.3 because that's what the problem was asking us to find. So our total for Joe is 318.72 miles. Perfect. All right, number 3 is a rounding question. Man, these rounding questions got everyone before we left school. So we are rounding to the whole number. Remember when we did this in class before we left, everybody wanted to round to the thousandths place. But what I need you to think about is, where does the whole number begin in this problem? I see a decimal. So this is the tenths place, and my whole number starts right here. So we need to decide, is 4,892 close to 4,892? Or is our whole number, entire number, going to round us up to 4,893? Those are your two options. So let's think about it on a number line. I've got 4,892 here, 4,893 here. Those are our two whole numbers. Now, you can think about this problem like money, like having $4,892.68. Well, I know the halfway point would be $4,892.50, because half of a dollar is 50 cents. So if I was to put roughly on the number line $4,892.68, I would say maybe it fell right here. $4,892.68, right? A little more than 50 cents, but less than the next dollar amount. So if I'm using the halfway benchmark to round, I am closer to 4,893. And that's how you round to the whole number. If you wrote 5,000, then you did not round correctly. Hope that number line visual was helpful for you all. All right, let's look at number 4. Number 4 says, I love this problem. There are 553 chairs in the school auditorium. The principal wants to put 26 chairs in each row. How many rows will we need to have? So if I am putting something into rows, I know that I am dividing the chairs into rows. So I know I need to divide 553 by 26. Now, I didn't bring scrap paper today, so wish me luck. I'm going to do 553 on the calculator since this is a word problem, and I'm going to divide it by 26. So when I do that, I can make 21 rows, and it looks like I have a leftover. So let me see if I can do this out for you. So 26 can't go into 5. 26 can go into 55 2 times. 26 times 2 is 52. So that means 33. 26 can go into 33 one time. So 33 minus 26 is 10 chairs left over. I'm going to let you look at that for a second. So if I have 553 chairs and I divide them with 26 chairs in a row, I can make 21 rows, and then I'll have 10 chairs left over. When you did it on the calculator, you saw 21 rows, and then you saw the leftover chairs as a decimal. So that's what happens when you divide on a calculator. If you have a remainder, it shows up as a decimal. So that's why I did it out for you here, so that you can see I actually have 10 chairs left over. All right, now going back to the problem, it says, well, how many rows will the principal need to make sure all the chairs get put into rows? If you said that we need 22 rows, you are correct. This is an interpreting remainder problem. That means I'm going to make 21 rows, but these 10 chairs we are not going to put back in the closet. The teacher wants to you know what? Now that I'm looking at this, I would take my answer back. So let me go back and read the problem. There are 553 chairs in the school auditorium. The principal wants to put 26 chairs in each row. How many rows will we need to have? You know what? I disagree with my answer. And I thought about remaking the video, but you know what? I want you to see my thinking through this. So now it says, how many rows will he need to have? So If 26 chairs can go into each row, then it looks like we're only going to make 21 rows. Now, if the problem specified that we needed to use all of the chairs, then I would say 22 rows. But when I'm reading over the problem again, it says the principal wants 26 chairs in each row, so that means we can only make 21 full rows of 26, and then the 10 left over, I guess, are going to have to go back in the closet because the principal only wants 26 in each row. She doesn't want those 10 chairs to make a 22nd row. Okay? All right, let's move on to number 5. Thanks for being patient with me. Listen, even as a teacher and I'm doing math, sometimes I think a little too quickly, and I really need to step back and think about the math that I'm doing. So I hope that my mistake was able to be clarified with you on that problem. All right, number 5. Joe had 5 packs of gum and 4/5 of each pack was already chewed. How many packs of gum was chewed in all? So he has his 5 packs drawn out, and he has 4/5 of each pack shaded, and it wants to know how many packs of gum did he chew in all. So what I need to do then is I need to make full packs. So I'm going to show you with the picture, and then I'll show you with the math. So I'm going to take this piece of gum that he's already chewed, and I'm going to add it here. I'm going to take this piece of gum that he's chewed and add it here. I'm going to take this piece of gum that he's chewed and put it here, and then this piece of gum and put it here. So these are all gone, and it looks like I have 1, 2, 3, 4 packs. Here's the math behind it. You can do 4/5 of a pack 5 times. So 5 times 4 equals 20. And then you can write 5/1, and 1 times 5 is 5. Remember, your fraction bar means division, so 20 divided by 5 equals, and we should put 4 here. Let me back up a little bit. You can see the picture, and you can see the math. All right. Good work today. Thanks for sticking with me for number 4. That's a tough one. I love you guys so much, and I will see you tomorrow, okay?